set it out as a quiz show, and then people who were like a bit shy will come out.
So everyone gets to write an answer, maybe.
60. It's gonna, all these are 20, like whatever 20 diameter. I'll knock 3 off and change the size, and we'll just say because of the size of this we estimate how many balls are gonna.
Yeah, and then we show it to them. Like so can fit it's a quiz thing. You can ask them how many they think is gonna knock off the end.
If we look for what other experiments and practicals have been done before, then we can just take ideas from that.
For Friday, should we all do like a page of research on linear momentum? I'm thinking tennis ball for the practice.
So we've got marbles, tennis balls, anything like that.
After sharing their initial ideas, Richard arranged for the learners to use the internet for a short time. This was to help them quickly make connections with the different aspects of the topic.
Well, when I first saw the title, The Conservation of Linear Momentum, it is, as Wes said, it's a daunting and it just looks complicated, and when you just out of the blue, you're given all these formulas to work out and asking what like the second law of Newton is, you just don't know what it is. But then went on the internet and things started like fitting in place, like you get to understand it a bit more when you read about it a bit more. But over the course of 4 weeks, I think we should be able to give a good presentation on it.
Once you start looking on the internet, it gives you examples of what it is. You realise that there's other stuff in real life that you see that happens to, but you don't realise what the name for it is.
Yeah, it's basically what they said, like Dale said, like everyday life.
I think it's going to be a challenging task. It's not only trying to learn the information yourself, you've got to teach other people it. You've got to give them questions, demonstrations, diagrams. You've really got to know it yourself to be able to teach it, and that's where it'll help us in the long run.
He wanted to know like how we want to be taught, sort of thing, instead of just bringing in any old way. He wanted to know how we learn the best.
I think that sometimes you get teachers, they just give you loads of information and just read through it like every week, but doing it a different style every so often, it sort of changes your like concentration and that, and you can take more in, I think, from a different method. So
Different trick shots, come up with some trick shots on the snooker table.
I learned that even though they think they know nothing, they have got some idea in there in the background. It's just bringing that to the foreground so they do realise that, yeah, I've got an idea about this, but I didn't realise I knew a little bit about it.
Yeah, so how are you going to demonstrate the conservation of momentum?
From one ball to the other. And we're thinking having a little ramp with like a groove in it for the ball to roll down. And say if we've got, I don't know, 5 gram balls, say if we've got 4 of them there, and we've got, I don't know, like a 20 gram ball up here, you roll that down, we could say, like we've been talking to Richard, we could say that we think 4 of them balls are going to move forward because the momentum of that is going to carry on to the other ball, so it's going to move a weight of 20 and leave 1 there. So we haven't really looked into it much, but we're going to have a look around the workshop after this little interview and see what we can do.
Looking like a decent enough cup, but if it'll actually work, I don't know.
Will because the ball fits in there.
Well, it's starting to flex a bit. Because hopefully the balls aren't going to run on there.
Oh, well, it's running the other way.
Yeah, but it still looks good when it's... yeah. Better. That'll be alright. Roughly, you maybe look at it. It's going to be about 32. Start of the curve's right there and the end of the curve will be about there, right? Yeah. Don't get the bottom of it. Leave it at that. Don't hold it there. Pass me one of those shapes. Just check the height from the table to the thing. Watch your hands. Oh, we're going to walk on this.
I did a few sketches and stuff, but quite a few people are doing like they're doing the snooker, and other people are doing like a ramp with a ball. And we thought it was all a bit normal, so I thought we'd try something a little bit different.
Basically, the original plan that we thought of was to use 2 remote control kit cars and then obviously drive them into each other. One will be loaded up with weights. But obviously, we then found out we were obviously down to 1 car due to one of them being broken.
From ramming it into things, probably.
Yeah. So we thought, well, we've still got one car, we'll have to just improvise with weights and another movable object to prove our theory.
Another dimension to all this, Richard, was the diaries.
Yeah, so, like as I say, these are their ideas that, as they've been going along, they've put the dates on there, showing when things are happening. He's mentioned it here, but before giving it, I had to do a little test, scary, because I knew nothing about it. Well, what I didn't want to do is just set them the task, leave them for 3 or 4 weeks, and then come back and see the results. I needed to know what was going on and learn from it and sort of see, right, this is what they've done, and this is what they was thinking at the time.
Did they work on this continuously? 3.5 weeks?
Maybe we're given a half an hour slot where they can just go and do a little bit of research or something like that. They probably had around about 6 hours to do it all.
Right.
That's another reason for me keeping an eye on these diaries so that I can go and gee them up.
After 3.5 weeks' work, they had to give their presentations. They had been encouraged to integrate their presentations with a demonstration and include some form of assessment.
It's the quantity of emotion the body possesses, which means like its mass and its velocity, like the speed it's travelling on at, kind of.
Because we're doing them ourselves, we've got to think, right, how am I going to put the message across to other people? So if you put into the things that are going to catch your attention, you know that it's going to catch the other people around you.
Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. I think that by not just learning it yourself, but like teaching it to other people, you kind of like get a better understanding of it yourself, and when you teach it to other people and in more practice and that, so when you go back to your companies and you won't be so like baffled when it comes to things.